Kuzambo. Welcome to Bhutan e-learning program. My name is Ngaung Chogel, a teacher from Yangchin Gasal MSS. Today, in this lesson, I'll take you all through the concept, the hydrocarbon, a lesson designed for Key Stage 4, Class 9 and 10. At the end of the lesson, you would be able to define the term saturated and unsaturated hydrocarbon. You will be also able to name alkene and alkyne. At the end of the lesson, you would be also able to write the molecular formula of alkene and alkyne. Now to begin with, the hydrocarbon as an organic compound. You know, organic compounds are the compounds that contain carbon and hydrogen, along with the other elements like nitrogen, oxygen, and sulfur, etc. And carbon is an essential constituent of any of the organic compound. Therefore, carbon plays a vital role in any of the organic compound. As such, organic compounds are also sometimes referred to as the carbon compounds. Today, there are more than 10 million organic compounds, out of which the most simplest form of organic compound is the hydrocarbon. Now let us look into what hydrocarbon is. Now here you can see the concept hydro refers to hydrogen, and of course the carbon refers to the element carbon. As such, hydrocarbons are the compounds composed of carbon and hydrogen. So these compounds called as hydrocarbon are basically built up of the two elements, that is carbon and hydrogen. Now let us look into the classification of hydrocarbon. Hydrocarbon in general are classified into two classes. The first one is called as the saturated hydrocarbon. Other one is unsaturated hydrocarbon. In the following slides, I would take you through why the certain kinds of hydrocarbons are called as the saturated hydrocarbon, and on the other hand, why the certain kinds of the hydrocarbons are called as the unsaturated hydrocarbon. Example of the saturated hydrocarbon we have is alkene. Likewise, the hydrocarbon that is unsaturated hydrocarbon is classified into two classes. The first one is alkene and other one is alkyne. Now if you look into those three compounds, the alkane, alkene and alkyne, you will be able to make out they have different suffix. Like in case of alkane we have ane, in case of alkene we have ene, and in case of alkyne we have the suffix as yne. These represent the nature of the bond present between carbon to carbon in hydrocarbon. As such, in case of alkane contains all single bond between the carbon atoms. So your focus here should be on just two elements, the carbon and hydrogen. So when there are more than two carbon atoms attached to form what is called as the hydrocarbon, alkane is one class of hydrocarbon which contains single bond between two carbon atoms or more than two carbon atoms. In case of alkene is also a kind of hydrocarbon which is grouped as the unsaturated hydrocarbon, which contains double bond between two carbon atoms. And finally, alkyne is an unsaturated hydrocarbon which contains triple bond between two carbon atoms. Now, before we look into the deeper part of the hydrocarbon concept, let us look into the very important characteristics of carbon and hydrogen. Because as spelled out in the earlier slides, carbon is an essential constituent of the hydrocarbon and plays a very important role. Therefore, if you look into the periodic table, you would find in the second period in group 4A the element carbon with atomic number 6 and then with the symbol C. This is element carbon. Likewise, if you look into the periodic table, you will also see the element hydrogen with atomic number 1 and then with the symbol H. So these are the two building blocks of the compound called as the hydrocarbon. Carbon has atomic number 6, which also means that carbon has 6 electrons in its atom. And you know then the configuration, the electronic configuration of carbon is 2 and 4. As such, carbon is not a stable atom. Remember, if the atom has to attain the state of stability or noble gas configuration, the atom must have 2 electrons in the outermost shell if the outermost shell is K shell. On the other hand, if the outermost shell of the given atom is besides the K shell, that is L shell, M shell, N shell, then the atom must have 8 electrons in the outermost shell. Then only atoms are considered to have attained the state of stability or the noble gas configuration. As such, if you look into the configuration of carbon, you will see there are just 4 electrons in the outermost shell. So as to attain the state of stability, carbon must have another 4 more electrons. Therefore, carbon forms 4 covalent bonds to attain the state of stability or the noble gas configuration. On the other hand, hydrogen as a constituent of the hydrocarbon has atomic number 1, has 1 electron, and it has the electron configuration as 1, which means it has 1 electron in the K shell, which is also its outermost shell. Therefore, if hydrogen has to attain the state of stability, then it must have 2 electrons in the K shell. As such, hydrogen forms single covalent bond to attain the noble gas configuration. Taking these important characteristics of carbon and hydrogen into consideration, now let's look into how carbon is linked to hydrogen in hydrocarbon. Let's say, for example, in this diagram, you see carbon has 4 valence electrons, and in order to attain the noble gas configuration, it will form 4 covalent bonds with the hydrogen atoms. And on the other hand, remember also, hydrogen will always form just single bond because it needs to just have another 1 more electron to attain the duplet configuration. So this is how carbon get bonded to hydrogen, attaining the state of stability. So carbon now then will have 8 electrons, and each one of those hydrogen bonded to carbon has 2 electrons each. The next one is carbon to carbon bond. In hydrocarbon, one carbon is linked to another carbon. In such cases, it is also important for us to also know what type of bond is being formed between carbon to carbon. When 2 carbons are connected to each other, there are possibilities that carbon can form single covalent bond involving 1 pair of electrons. At times, carbon can also link to one another, forming double covalent bond involving 2 pairs of electrons. And finally, carbon can also form triple covalent bond involving 3 pairs of electrons. Now, one class of hydrocarbon we have is saturated hydrocarbon. An example of saturated hydrocarbon we have here is alkene, represented with the general formula CnH2n plus 2. Here, the N stands for positive integers. If the number of carbon atoms is known to you, then it is obvious that from this general formula, you can also find out the number of hydrogen atoms present in this particular compound, that is hydrocarbon. So let's look into finding some of the families of the alkane using the general formula CnH2n plus 2. So this is the general formula of alkene. Using this formula, you can find out the members of the alkene. So when N is equal to 1, what could be the value of H? So you can find from here, N is 1, H should be equal to 2 times 1 plus 2. So C1, H should be equal to 2 ones are 2 plus 2 is CH4. So we write it as CH4. So H is equal to 4, and then finally we have the formula of the first member of alkane is CH4. I think you are with me. Now let's see, when N is equal to 2, can you guess the value of H? Think for some time and then try to find out what is the value of H when the N is equal to 2. Using the same formula here, when N is equal to 2, when N is equal to 2, H should be equal to 2 times 2 plus 2 is equal to C2, H2 to the 4 plus 2 is H6. So therefore, the value of H here is 6. Remember, we are here dealing with the hydrocarbon, the organic compound composed of just carbon and hydrogen. Therefore, the formula of this compound will be with hydrogen 6 and number of carbon atom 2. Combining the two together, we get the formula of the next member of alkane is C2H6. Let's try with the next one. When N is equal to 3, I think by now you know the pattern of how the members of the alkanes are being found out. So when N is equal to 3, that means C is equal to 3, H should be equal to 2 times 3 plus 2. So it should be C3, H6, 3 to the 6 plus 2 is equal to H is equal to 8. So this is the next member of alkene. And then by now you know when N is 4, you know how to find out the value of H. H should be equal to 10. And then this is the formula of the next member of alkene. Following the same process, you can still find out the rest of the rest formula of rest alkane family. To draw the structure, now we will try to look into how to draw the structure of these compounds. For example, methane, we have CH4 here. If you are to draw the structure of methane, we have here carbon bonded to 4 hydrogen atoms. Likewise, this is the structure of C2H6, where 2 carbon atoms are bonded through a single covalent bond, and rest of the bond is being bonded with the hydrogen atoms. This is the structural formula for C3H8, and then you can also see here the 3 carbon atoms are bonded to one another through a single covalent bond. And finally, you can also see here when carbon is 4, these 4 carbon atoms are linked to one another through a single covalent bond, and the rest of the valences of the carbon are fully satisfied with the carbon to hydrogen single bond. So you have seen the structure of all these compounds, and then you must also have seen like there are single bond between carbon to carbon, and it is alkane which have single bond between carbon to carbon. As such, they are called as saturated hydrocarbon. But then how to name this compound? It's quite interesting to name the compound. Let's see how do we name those compounds? CH4, C2H6, C3H8, C4H10, what could be their names? Basically, naming of hydrocarbons are based on the number of carbon atoms. So I have the table here. When the number of carbon atoms is 1, we give the name to the hydrocarbon as meth. Meth should be given as a prefix. When the number of carbon atoms is 2, we name the hydrocarbon as eth, means we assign eth as a prefix to this compound. When the number of carbon atom is 3, we assign the wat prefix, that is prop. And when the number of carbon atom is 4, then we assign the wat prefix, that is but. And when the number of carbon atom is 5, we name the compound as pent. Remember, pent is given as a prefix. When the number of carbon atom is 6, we give the prefix as hex. And when the number of carbon atom is 7, we give the prefix to the compound as hept. And when the number of carbon atom is 8, you give the prefix to the compound as oct. When the number of carbon atom is 9, we give the prefix to the compound as non. And finally, when the number of carbon atom present in the hydrocarbon is 10, we give the prefix as dec. Taking those things into now consideration, you can really name those compounds. It's very simple. Now, what should be the name of this compound? This compound CH4 has only 1 carbon atom. Therefore, we can give or assign the prefix meth to this compound and add ane from the name of the alkane, that is ane, as a suffix. So we have the name as methane. Let's try the next one. Are you ready? The next compound we have is with the formula C2H6. Since this compound has 2 carbon atoms, we can assign the prefix eth and then add ane, it becomes ethane. Next compound we have is C3H8, which have 3 carbon atoms. So we add prefix prop and then add ane, it becomes propane. And likewise, the hydrocarbon with the alkane, that is with the formula C4H10, has 4 carbon atoms. 4 carbon atoms. So 4 carbon atom represents the but, and then we add ane, it becomes butane. So this is how we name the alkane, following the CnH2n plus 2 as a general formula, and based on the number of carbon atoms. Now, why are alkanes referred to as saturated hydrocarbon? Let's take this example. This hydrocarbon is now reacting with the hydrogen having 1 valence electron. So what you would expect is, since this hydrocarbon is already saturated, this reaction does not happen. Likewise, if you take another example of the alkane, that is C2H6, it will not combine with the hydrogen atom because these compounds are already saturated. The reason being, alkanes are known as saturated hydrocarbon because all the 4 valencies of carbons are fully satisfied by carbon to carbon and carbon to hydrogen single bond, and as such alkanes are unable to take any other atoms in their molecule. So this is the reason why alkanes are referred to as unsaturated, saturated hydrocarbon. So let me take you through a question here based on what we've learned about the alkane. The question says, what is the name of the alkane with 6 carbon atoms? Do you think you can do this? We can use this table whereby naming of hydrocarbon is based on the number of carbon atoms. So since we are asked to find the name of the alkane with 6 carbon atoms, when there are 6 carbon atoms in the hydrocarbon, you give the prefix as hex and add ane from the name of the alkane as a suffix. So we have the name of this compound as hexane. Let's take into another question and try to answer to this question. The question says, what is the formula of heptane? You can again use this table, and then you can as well use the general formula of alkane to write the formula for the compound heptane. Remember, hept represents 7 carbon atoms. When the number of carbon atoms is 7, then you can also find out the number of hydrogen atoms. So number of hydrogen atoms should be 7 times 2 plus 2 should be equal to 16. So this is the formula of the compound, which is heptane. So this is all about the alkane. Now let me take you through the unsaturated hydrocarbon. Unsaturated hydrocarbon has the double bond or a triple bond between 2 carbon atoms, and unsaturated hydrocarbon is classified into 2 classes, alkene and alkyne. Alkene contains double bond between 2 carbon atoms, and alkyne contains triple bond between 2 carbon atoms. So let's see first of all the alkene. Let's try to find out in a similar manner that we have used in the earlier case about how to find out the members of the formulas and then the members of the alkane. So when n is equal to 2, so since alkene has general formula CnH2n, when n is equal to 2, so when n is equal to 2, then A should be equal to, let's find out. So using this general formula CnH2n, this is a general formula for alkene. Substituting the value here, C is 2, that is n is equal to 2. A should be equal to 2 times 2. So C2H is equal to 2 to the 4. N is equal to 4. So this is the formula of this compound C2H4. Then when n is equal to 3, then H should be equal to 6. So in case of alkene, the number of hydrogen atoms is just double of the number of carbon atoms. And this is the formula of this compound C3H6. Now when n is equal to 4, H should be equal to 8. And we have this formula of next member of alkene as C4H8. So when n is equal to 5, can you guess now? When n is equal to 5, what could be the value of H? The value of H is equal to 10. And then this is the formula of this compound. If you try to draw the structure of any one of these compounds, the family of alkene, you will always find double bond, at least one double bond between two carbon atoms. So this is the structure for C2H4, where you find double bond between two carbon atoms, and rest of the valence of the carbon is being satisfied by the hydrogen, bonding with the hydrogen. This is the structure for C3H6, where again you will find double bond between two carbon atoms. And this is the structure for C4H8, where four carbon atoms are combining together, linking to one another, but then you also find one double bond between the two carbon atoms. Now, in a similar manner, naming of the alkene can be also done based on the number of carbon atoms. Since this compound with the formula C2H4 has two carbon atoms, the prefix eth is given to this, and then we add ene, becomes ethene. Then this compound C3H6 has three carbon atoms. We can give the prefix as prop and then add ene, it becomes propene. The compound with C4H8, it has four carbon atoms. So what do you expect the prefix to be is but, and then to add we add ene, it becomes butane. And this compound C5H10 has five carbon atoms. So we assign pent as a prefix, and then to it we add the suffix ene, it becomes pentene. So this is how we name the alkene. We can still go on with n is equal to 6, what could the value of H? And then we can still name those compounds without having to actually by heart. Another question that comes to our mind is, why are alkenes referred to as unsaturated hydrocarbon? Let me take you through the example here. This is alkene with a double bond between two carbon atoms. It reacts with the hydrogen molecule having one valence electron each, where they are forming a bond. Now, the double bond in alkene represents two covalent bonds. Out of the two covalent bonds present between two carbon atoms, one of the bond is weak bond. It opens up, and an addition reaction takes place. So let's see. This is how the bond opens up. One of the hydrogen goes there, get attached to this carbon. A bond is being formed. New bond is being formed. Likewise, this hydrogen get attached to that second carbon atom. A new bond is formed. And finally, we have a saturated hydrocarbon produced from unsaturated hydrocarbon through the addition of hydrogen atoms. The double bond present in alkene is the combination of two bonds between the carbon atoms, and one of the bonds is a weak bond and breaks easily, and addition reaction takes place, which is why we say alkenes are the unsaturated hydrocarbons. Now let's have another round of activity about the alkene. What is the name of the alkene with 5 carbon atoms? So when the number of carbon atoms in the hydrocarbon is 5, we give the prefix as pent. And since we are talking about the hydrocarbon alkene, then we add the suffix as ene, because that compound would have double bond between two carbon atoms. So this is the name of this compound, that is pentene. Now let's look into another question on the alkene. What is the formula of octene? So ene represents double bond. So oct means there are 8 carbon atoms, and if there are 8 carbon atoms, what could be the number of hydrogen atoms? Can you find the number of hydrogen atoms? When the carbon atom is 8, should be equal to 16. So this is the formula of the compound C8H16, that is called octene. I think you are with me. I think you got what I am saying. Finally, let's look into the next unsaturated hydrocarbon, that is alkyne. Alkyne has a general formula CnH2n minus 2, where n represents again the number of carbon atoms. So alkyne has general formula CnH2n minus 2. So when n is equal to 2, let's find out what's the value of H. So substituting the value of n as 2 here, H should be equal to 2 times 2 minus 2. So it should be equal to C2, H should be equal to 2 to the 4 minus 2 is equal to 2. And this is the formula of this compound, C2H2 is the first member of alkyne. When n is equal to 3, following the similar pattern, using the same general formula here, CnH2n minus 2, when n is equal to 3, H should be equal to 3 to the 6 minus 2 should be equal to 4. And this is the formula of this compound. Next member of alkyne is C3H4. Then when n is equal to 4, what should be the value of H? Can you find it out? The value of H should be equal to 6. That is, H should be equal to 4 times 2 is equal to 8, minus 2 is equal to 6. And this is the formula for this compound. C4H6 is the third member of alkyne. If you are at all asked to draw the structure of these compounds, which are the family of alkyne, you will always find triple bond between 2 carbon atoms at least. At least one triple bond between 2 carbon atoms. This is the structure of C3H4, where you find triple bond between the first carbon and second carbon. And this is the structure for the C4H6. Now, how to name those compounds? What is the name of the compound with C2H2 as formula? What is the name of the compound with the formula C3H4? What is the name of the compound with the formula C4H6? So since this compound has C2, carbon 2, we can assign the prefix as eth and then add YNE, because it contains triple bond, it becomes ethine. Ethine is the name of this compound. Let's try naming this compound with the C3H4. Since there are 3 carbon atoms, the prefix prop is added and then YN is added as a suffix. The name of this compound becomes propyne. This compound now has 4 carbon atoms. So when it has 4 carbon atoms, we assign the prefix as but and then add YN becomes butane. So this is how we name the alkyne. Now still we have not answered why alkynes are considered as an unsaturated hydrocarbon. To answer this question, let's take into the consideration this reaction as consideration. Let's consider this reaction where the alkyne with the triple bond is combining with the 2 hydrogen atoms. Remember, when there are triple bond between 2 carbon atoms, 2 of the bonds are weak bond, breaks easily, and then addition reaction will take place. So let's see, this is how bond opens up. One of the hydrogen get attached to this carbon. Another hydrogen get attached to this carbon, forming a bond. a double bond compound is being produced. This compound is still unsaturated. This falls under the class that is alkene. Therefore, this compound alkene will undergo again the addition reaction further, where it combines with the hydrogen molecule having one electron each, where they have formed the bond sharing a pair of electrons. So out of the 2 bond, 1 bond is weak, breaks up, and an addition reaction takes place. So one of the hydrogen get attached to this one, forming a bond, and another hydrogen get attached to this, and finally we have a saturated hydrocarbon formed as a result of addition of hydrogen atoms to our molecule. The triple bond in alkyne is the combination of 3 bonds between 2 carbon atoms, and 2 of the bonds are weak and breaks easily, and addition reaction takes place. Therefore, alkynes are also referred to as unsaturated hydrocarbon. Now we have dealt enough about the saturated and unsaturated hydrocarbon. Let's look into how to distinguish, how to differentiate the saturated hydrocarbon from the unsaturated hydrocarbon. So let's look into 2 tests. The first test is the bromine test. Let's say, for example, we have 2 unknown solutions here, solution A, solution B. Now we do not know which one of these 2 are saturated or unsaturated. Let's see, we find out whether A is saturated or B is saturated, or whether A is unsaturated or B is unsaturated, using a bromine solution which is orange in color. Let's try to add few drops of bromine solution to this compound B, and then you observe the orange color bromine do not disappear. The solution B do not decolorize the bromine solution, in other words. Similarly, you try to add few drops of bromine solution, orange in color, and then you could observe here that the orange color bromine disappears in unknown solution A. So which one is unsaturated and which one is saturated? Let's find out. Yes, solution A is an unsaturated hydrocarbon because the unsaturated hydrocarbon decolorizes the orange color bromine solution. And on the other hand, solution B is a saturated hydrocarbon because the saturated hydrocarbon does not decolorize the orange color bromine solution. So this is how we test the saturated and unsaturated hydrocarbons using a bromine solution, called as the bromine test. Another test that we have here is the Bayes test. Let's consider again, we have unknown solution A and then B, and then here the reagent we are taking is alkaline potassium permanganate solution, which is purple in color. Let's try adding few drops of alkaline potassium permanganate solution, which is purple in color. The unknown solution B does not decolorize the purple color potassium permanganate solution. Let's add few drops of the alkaline potassium permanganate solution to it, solution A. It decolorizes the purple color potassium permanganate solution. So which one is saturated and which one is unsaturated hydrocarbon? Let's see. Solution A is an unsaturated hydrocarbon because the unsaturated hydrocarbon decolorizes the purple color of potassium permanganate solution. And on the other hand, solution B is a saturated hydrocarbon because the saturated hydrocarbon does not decolorize the purple color of potassium permanganate solution. Now, Let's look into the hydrocarbon in our daily life. Where do we use hydrocarbon in our day-to-day life? Hydrocarbon, that is ethene in the form of hydrocarbon, is used in manufacturing of buckets, used in manufacturing of plastic bottles, used in manufacturing of flexible pipes, and the plastic, of course. Likewise, hydrocarbon is used in the lighters and the LPG. The LPG and the lighter contain the hydrocarbon called as the butane. And then we also use hydrocarbon in our everyday life, mainly as a fuel. And finally, hydrocarbon, that is ethene as an hydrocarbon, is used in artificial ripening of fruits. I have some home tasks for you. Take some time and then try to answer those questions. The first question says, what is the formula of the compound hexane and heptane? To answer this question, you can always make use of the table which talks about the number of carbon atoms, naming of hydrocarbon based on the number of carbon atoms. The next question says, what is the name of the alkyne with 4 carbon atoms? Here as well, we can also use the table that I have been using throughout the slides. It will help you answer these 2 questions. And of course, you can also use the general formula of alkene, and alkyne based on the type of question being asked. Finally, let's look into what we've learned today. So in this lesson today, I have taken you all through what is hydrocarbon. We have also learned about the 2 classes of hydrocarbon, the saturated and unsaturated hydrocarbon. Alkane is an example of the saturated hydrocarbon, and then alkene and alkyne is an example of unsaturated hydrocarbon. You also know, like, alkane contains single bond between carbon atoms. Alkene contains double bond between the 2 carbon atoms, and alkyne contains triple bond between the 2 carbon atoms. Which is why we know alkene contains double bond, it is referred to as unsaturated. Likewise, alkyne contains triple bond between 2 carbon atoms. Alkynes are also referred to as unsaturated hydrocarbon. Thank you for attending this lesson. Hope you enjoyed attending this lesson.